This is for Year 12 Specialists. It comes out of 8E, question number 3, and it's using the method of integration called integration by recognition. They tell me to take a derivative, then hence use that derivative to find this length. Okay, so I need to take this derivative. So if f of x equals log base e of sec of x plus tan of x, then f dash of x will be 1 on top of all of that, sec of x plus tan of x, times the derivative of this. Now sec is 1 on cos of x, therefore that's cos of x to the negative 1. So this derivative will be negative 1 cos of x to the negative 2 times negative sine of x. So that's the negative 1 comes down, this to the power of negative 2, then the derivative of the inside. Plus the derivative of tan, which is sec squared of x. So a little bit of simplification here. I've got 1 on top of 1 on cos of x plus sine of x on cos of x, which is cos of x on 1 plus sine of x. And here I've got negative times the negative, so I've got sine of x on cos of x squared plus 1 on cos of x squared, which is the same as sine of x plus 1 on cos of x squared, and that this cancels with this, and this cancels with one of those to leave me with 1 on cos of x as being the derivative. Okay, so what do I have now? I know that d dx of log of e sec of x plus tan of x equals 1 on the cos of x from my answer up there. So if I integrate both sides with respect to x, the integral of the derivative of this is just that, log base e of sec of x plus tan of x equals the integral of 1 on cos of x dx. Okay. If I'm looking for this distance, I need to use this rule. So I'm wanting the integral, which is the integral from 0 to pi on 4 of the square root of 1 plus d dx of log base e of cos of x squared dx. Okay, d dx of log base e of cos of x will equal 1 on the cos of x times the derivative of cos of x, which is minus sine of x. And then if I square that, I'm looking for sine x squared on cos x squared. So I'm looking for the integral of the square root of 1 plus sine of x squared on cos of x squared dx from 0 to pi on 4, which equals the integral from 0 to pi on 4, the square root of, putting them all on top of the cos of x squared plus sine of x squared dx. My numerator is 1, so I'm looking for the integral from 0 to pi on 4, the square root of 1 on cos of x squared dx, which is integral from 0 to pi on 4 of 1 on cos of x dx. Now I know from over here that the integral of 1 on cos of x is equal to this. Therefore I can use this for that integral, and I have equal to log base e of 1 on cos, which is sec, plus tan of x from 0 to pi on 4, which will equal log base e of 1 on the cos of pi on 4 plus tan of pi on 4 minus log base e of 1 on the cos of 0 plus the tan of 0, which will be log base e of 1 on root 2 is root 2 plus 1 minus log base e of 1 plus 0. Log base e of 1 is 0, so the answer is going to equal the log base e of root 2 plus 1, and that's the distance.